Oh no. Oh, there you go. Hey everyone, welcome back to your next lesson. So in this lesson, I really want to encourage you, if you are someone that printed out the identities, the trig identities that we have worked with when we did simplifying and proving and solving, right? That's what we've done so far up to this point. I would really suggest that you have them out because we're actually going to be adding to them. Right, and if you didn't have it printed and you had your notes written down somewhere, you might want to add this to those notes so you kind of have a compilation of all of the different identities that you can reference while you're studying and practicing and checking your own understanding of this. So in this video lesson, we are going to be talking about proving and solving trig equations using something called the sum and difference identities. Okay, so this textbook are suggested to practice with this content from this video. There's also some other resources that are posted on the page that I encourage you to go ahead and take a look at. So that being said, we're going to start off by deriving the cosine difference identity. I was getting ahead of myself. Okay, so we'd like to express this right here. So so you can see how this is the difference identity. You're finding the difference of two angles here. And so we want to express cosine mu minus mu in terms of just sine and cosine functions of mu and nu. So we don't want there to be, we want to we want to re-express this, I guess is what I'm trying to go with. So we're going to go ahead and let's go back to what we know. Okay, so right here is the angle mu, right? So you're starting from the positive x-axis and going counterclockwise. And so this point here, we've got our handy unit circle, is cosine sine of that angle, right? Okay, so we also have another angle, right? And so there's that angle. And so again, that point then would be cosine of nu and then sine of nu. But we're trying to find the difference between these two. So if we found the difference, we would really be focused in on this angle right here, right? That's mu minus nu. For the purposes of this, we're just going to call that theta to make it a little bit simpler for us to talk about and talk through. So that right there is theta. And so we're trying to figure out how we can, essentially what's another way that we can write this, right? Cosine of theta is going to equal to what is what our goal is. So we can figure out that distance of that nice purplish, pinkish line right here, right? So if we go back to the distance formula, hopefully you remember that. It's just the Pythagorean theorem as well. We can figure out that distance. Okay. So right here is that distance, that purple distance, right? So you're doing x, distance formula is the square root of x minus x squared, or x1 minus x2, whatever you want to say, plus y1 minus y2 squared, and the square root of that whole thing. So that's going to be that distance. You're doing cosine minus cosine, sine minus sine squared, right? It's really just the Pythagorean theorem. I can make this into a nice right triangle. Oh, this distance right here is going to be cosine minus cosine. This one's going to be sine minus sine, right? It's the change of x, change of y. And that's where you're getting that piece of it. Now that we know that side length, what can we do? Right? It's the unit circle. We know that's one, that's one. Well, we've got all three sides, so we can go back to what we learned about the law of cosines. And we can actually figure out what theta is, right? So if you remember the law of cosines, we had c squared equals a squared plus b squared minus 2ab cosine c, right? Assuming that this is angle c and this is side c is what I'm going with, right? So here we go. All right, so we've got this whole side squared equals 1 squared plus 1 squared minus 2 times 1 times 1 times the cosine of theta. And our goal is to solve for the cosine of theta, right? So when you square this, you get the cosine minus cosine squared plus sine minus sine squared equals 2 minus 2 cosine theta. Okay. So this is what happens when I multiply this out. Cosine squared minus 2 cosine, and you can see it's different angles that we're talking about here, so just be careful with that, equals 2, so you're just multiplying them both out, 2 minus 2 cosine theta. Well, we can also rearrange this, right? And I can take the cosine and the sine. What's that equal to? Oh, that should look familiar. That's just 1. That's the Pythagorean identity. And then you've also got cosine, sine here. Oh, that's also just 1. So what are we going to have on this left-hand side now, right? And then 1 plus 1 minus 2 cosine mu cosine nu minus 2 cosine mu, sine mu sine nu equals 2 minus 2 cosine theta. Okay, so let's take that. Let's see. Right, so what just happened there? Well, this is 2. If you subtract 2 from both sides, those are going to cancel. What can we do now? Right, our goal is to figure out what cosine theta is. What's the equivalent? Because remember, theta is mu minus nu. Divide by -2, and whoa, there we've got it. We've now re-expressed this. Right, so what I just found out, I'll put this over here, and remember again, this is theta. That was what we called theta way at the beginning of this. You can re-express it in this way. Okay, so why might this be useful? Why might this be something that we're doing? Well, we know how to work with special angles, but what if we didn't have a special angle? But we could express that angle that we did have as the difference of 2 special angles. Well, then there we've got it. We can actually simplify or solve or evaluate, right? So if that is true, right? So make sure I would add this, and I'll show it a little bit better in a few moments. But I would make sure this is something that you're adding to that note sheet where you have a bunch of the identities. Maybe on the back you can find some space. So if we know this, right? And so the cosine, it's cosine of each of the angles plus sine of each of the angles. Well, what happens if we're going to do the cosine sum identity, right? So we can express addition in terms of a double negative here, right? And so you're doing mu minus negative nu, right? And then just using what we've already said, I've got cosine of mu, cosine of negative nu, plus sine of mu, sine of negative nu, which is just equivalent to that, right? And so this was an identity that we had earlier, right? And you might even just be able to think of the, what is it called? Unit circle. But here we can talk about the odd even identities. Odd even identities, right? And cosine is an even function. So cosine of the negative angle is going to be equivalent to cosine of the positive angle. And so that's why we were able to go right there. I mean, you can also think about it as in terms of the unit circle. Say if I'm going to go up here versus I'm going to go down here with the same reference angle, I'm going to get the same cosine value. Whereas if I did that with sine, right, and I went up here versus down here with the same reference angle, I'm going to get the opposite output. And that's why that positive becomes a negative, because this right here is the same thing as negative sine of nu, right? So then you had a negative, and that's where this negative, you're multiplying a negative by a positive, and that's where that negative came from. Okay, so the cosine sum and difference identities, to sum that up, is cosine. We've got these two right here, right? And while you don't have to be able to necessarily prove them or derive them, I guess is a better way to say it, it is still a valuable thing to be able to come up with and to know that you can just use the tools that you have and the things that you have learned in this class and previously to actually come up with this, which is awesome and super neat. Okay, let's take a look at sine, sum and difference. So sine. Here, we're going to actually just let's use what we already came up with, right? Might as well. So sine right here, why am I able to do this? What is this coming from? Oh, this is coming from the cofunction, right? The sine of an angle is equal to the cosine of pi over 2 minus that angle, right? They're complementary angles. So that's where that's coming from. These two are equivalent. So then I'm able to just use one of the other identities here. So I want to go ahead and actually distribute that negative, and I'm going to look at them as you're adding these two angles right here, right? So distribute that negative and just group. So you've got pi over 2 minus mu plus nu. And then let's use the same identity we already have. So cosine of pi over 2 minus mu, cosine of nu minus, right? So this is what we already had. Cosine, cosine, minus sine, sine. Right, so that's how I'm expressing it. And then what is this equivalent to? Right, cosine, let's go back to the cofunction book. Cofunction identity. Well, this right here is just sine of mu, right? This right here is just cosine of mu. So that's where we're getting this right here. Sine of mu, cosine of nu, minus cosine of mu, sine of nu. Oh, goodness. If we went ahead, and I'll erase what I wrote there to make this easier for you to see. If we want to do the sum identity for sine, let's just pull on that, right? Let's make it subtraction. And we go ahead and use what we just came up with. And let's think about the odd even identities here. So cosine, again, this is going to be equivalent to just cosine. This is going to be equivalent to negative sine. So what's going to happen to this sine right in there? Oh, it's going to become positive. Right, so these are our sine, sum, and difference identities. Right, so we've done the cosine and the sine. We're also going to take a look at tangent, but of course, tangent is something that, if you know sine and cosine, you can deal with tangent, right? We know the quotient. So for tangent, sum, and difference, this is what we've got here. And so I'm not going to do them both, but let's say if we were dealing with this right here, that would be the same as sine over cosine. And let's see, we just came up with these, didn't we? So the sine is sine cosine. And then this is minus, right? Cosine sine over this right here. Let's see, is this the one I even wanted to do? I think it was. Yes, it was. Okay. I had a moment there. Cosine cosine plus, oh no, sine sine. Okay, so what I could do here, and this might not be like super intuitive, but let's say I know what my end goal is just to kind of show you where this is going. So I'm going to actually go ahead and factor out sine, let's see. I forgot what I was doing. I'm going to factor out cosine in the numerator, like cosine of mu, cosine of nu. And then in the denominator, I'm going to factor out the same thing. Okay, and when I factor that out in this first spot right here, well, I'm just going to be left with sine over cosine. So picture now if both of mu, right, which was my goal, right? I know I want to end up with tangent right there. So if I were to factor this back in, the cosines would cancel and I end up with sine of mu, cosine of nu, right? That's what I want. If I factor it out of the second term right here, I'm going to end up with, there's not going to be a cosine here anymore. I'm going to end up with sine nu over cosine nu. Okay, so that's the numerator. And the denominator, if I factor it out, well, this is just going to be a 1 plus sine is still going to be there. They're both going to be there, right? I'm going to have sine and sine over cosine mu, cosine nu. Okay, these will cancel. And then check out what I'm left with. Tangent of mu minus tangent of nu over 1 plus tangent of mu times tangent of nu. And oh, look, that's that identity right there, right? So if you can come up with that. I think the ones that are very important that you know and can work with are sine and cosine, right? So let's see how this comes up. And as I started to say a little bit earlier, the sum and difference identities can sometimes allow us to give an exact value for some non-special angle, something that we haven't been able to do without a calculator, right? So an exact, right? What I mean by exact is you don't need a calculator. Nothing's rounded. Like if there's a radical, the radical is going to stay. It's still going to be there. So, oh, sorry. I wasn't even paying attention to the fact that it was here. Find the exact value for the cosine of 75 degrees. Well, let's think about how we can express 75 as either the sum or difference of two special angles. I'm going to go ahead and do 45 plus 30. Right? And then right here, I'm dealing now with the sum. So I've got the cosine of 45 times the cosine of 30 minus the sine of 45, the sine of 30. Right, so the cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2 minus root 2 over 2 times 1/2. So I end up with, that's root 6 over 4 minus root 2 over 4, or root 6 minus root 2 over 4. Can't do anything else with that, right? So, but I'm now getting an exact value for an angle, not a non-special angle. Pretty awesome. Oh, perfect. I thought it wasn't going to fit, right? So I can do the same thing for all of these, right? So maybe I'm going to express, I'm going to kind of tell you how I would express it, and then you guys can go ahead and simplify it. Right, I would do the same thing with 30 and 45 here, which would give me what? I'm adding them. So I'd have the sine of 30 times the times the cosine of 45 plus the cosine of 30, the sine of 45. Right, and that's going to actually give me the square root of 2 plus the square root of 6 over 4. Would be my exact answer there. No calculator needed. What about the tangent of 15? I can express that. Let's think, sum or difference of special angles. I'm going to go ahead and do 45 minus 30. right? I mean, realistically, I could find the sine of the difference and the cosine of the difference and then do divide, right? Or if I wanted to use the tangent one, it's the tangent of 45 minus the tangent of 30 divided by 1 plus the tangent of 45 times the tangent of 30. When I do all of this, and I end up with, there's some interesting things going on here. I'm just going to go ahead and simplify it to 3 minus root 3 over 3 plus root 3. So I don't have any complex fractions. I do have a radical in the denominator, but I don't have any like fractions within my fractions. For example, number 4 here, now we've got pi over 12. So you've got to think about how you could re-express that. So I mean, I'm sure you might be able to think of some other things, but I'm going to go ahead and do pi over 3 minus pi over 4, right? So pi over 3, so I'm just thinking through it and saying, well, I'm going to do 4 pi over 12 minus 3 pi over 12, right? And when I simplify them, I get pi over 3 and pi over 4, which are both special angles, right? So start with a special, you got to think through. You need to make sure that they're both special angles. I don't want to end up with something like 5 pi over 12. That's not a special angle. We can't work with that. It doesn't help me at all. So then I can do sine of pi over 3, cosine of pi over 4, minus cosine of pi over 4, sine, oh, I messed that up. Cosine of pi over 3, sine of pi over 4. I switched that. And I end up with here, for example, 4, I get root 6 minus root 2 over 4 when I simplify it. And finally, down here for my last example, 7 pi over 12. I'm going to do, let's see, I could do something with, there's a lot of different ways I can do this one. I'm going to do 3 pi over 4 minus pi over 6. You might do it differently, and maybe you want to try it differently and see if you're getting it. Right, so 3 pi, not a lot of room for me here. Minus pi over 6, right? So 3 pi over 4 is the same thing as 9 pi over 12, minus pi over 6 is the same thing as 2 pi over 12, and so that gives me 7 pi over 12, right? I might have done something like, if I did 3 pi over 12 and 4 pi over 12, right? And I'm adding them, and so it looks just like this, but I'm adding them instead, right? That's fine as well. Oh, no, sorry. Well, what just happened? Oh, it's like, no. Sorry, guys. Did something interesting there. Oh, darn. Sorry. Okay, sorry. So here, just to finish this up, I would then have the sine of 3 pi over 4. That's a 3, I promise. Times the cosine of pi over 6 minus the cosine of 3 pi over 4 times the sine of pi over 6. And for this last one, what you will get is root 6 plus root 2 all over 4. Right? So you actually have the same thing, the sine of 75 degrees. Right? So, and again, like you can do those differently. These are supplements. 75 and 7 pi over 12, right? 75 and 105. That's why they have the same sine value. Pretty cool. All right, so you can also use the sum and difference identity to simplify trig expressions, right? So you can simplify it into one. So right here, it's good to, you want to recognize that that's the goal here of, oh, isn't this I've got sine of an angle, cosine of another angle, minus sine of that other angle. Well, I guess it's not really what I have. Cosine of an angle, right? This is just the same thing as sine of alpha or A minus B in my case. Right, so I can't find my pen. There it is. Sine of 73 minus 13, which, oh, check that out. Sine of 60. Oh, it's special. The sine of 60, well, what's that? Root 3 over 2. So something that we might not have known that we could work with or figure out without a calculator, you actually can with this identity. Right, and same thing here. So cosine of these two angles plus sine of those two angles is the same thing as cosine of, what is it, alpha minus, or A minus B. So this is the same thing as saying the cosine of 94 minus 18, which is the cosine of 70, what is that? Sorry, 76? Is that right? 94 minus 18? Yeah, right, which is not a special angle. But I mean, you could re-express that as something different. It's not, we're not going to be able to figure out, there's not special angles that work for this one. However, like maybe I could re-express something and figure out, then break it apart again into different numbers, right? Pretty cool. Finally, what you can also do with this is with the sum and difference identities, you can prove trig identities, right? So this is just, that's why you're adding it to that worksheet, is it's something, it's just another thing that you're going to be able to use and look for, just like we have the Pythagorean identities and you have the like quotient and reciprocal and cofunction, odd even, right? So we're going to use those. So for instance, this one right here. So the cosine of x minus y plus the cosine of x plus y equals 2 cosine x y. Cosine x cosine y, sorry. So this is where I'm going to choose to work on the left-hand side, and I'm going to make the left-hand side look like the right-hand side. But I can use these identities. So this right here is the same thing as cosine of x, cosine of y, plus sine of x, sine of y. Plus, this right here is the same thing as cosine of x, cosine of y, minus sine of x, sine of y. Okay. Oh, look, those are going to cancel. We're subtracting. And then here I've got two of them. So you've got 2 cosine x, cosine y. And that is the right-hand side. Right? QED, we're done. I'm going to wipe the square on that. Right, so tie it in, you're adding to what we've been working with. So this is a small hint for number 51 on those homework problems. I'm not going to go ahead and do it right now. We're going to work more with this when we see you in class. But this might be helpful to you, as you can split cosine 3x into cosine 2x plus x and cosine 2x minus x. Right? That might help you to work with it a little bit more, like break that one up, because that one is a bit challenging. So I would suggest that you go ahead and take a look at some of those practice problems before we see you in class, and just as you're practicing and prepping as well. Finally, there are, I don't know if you all are familiar with School Yourself or if we've used it in the past, but there's a website, School Yourself. It's also linked on the page as well as in this PowerPoint, or you can just go directly to School Yourself. And there's actually a bunch of videos there just that we've worked with. And so these four are like great to work with. right, like at this point, right? So it's the addition identities. We just did the sum and the difference, right? So those are the ones that are the most relevant right now. But then you can also go ahead and look at the one for the Pythagorean identities, which we've talked about, as well as the negative angle identities. And there's more on there as well. And so I encourage you to take a look at that. And it's a great website that just lets you kind of check your understanding as you're going. And yeah, so I encourage you to take a look at that. So with that being said, this was the sum and difference identities. There's a little bit more that we're going to be adding to this idea and these concepts in the next video. But this is practice with sum and difference identities, and I encourage you to do it and practice and continue working on the challenge problems as well. And we will see you soon.